Today we'll be learning how to determine the density of an object. In order to determine density, we first need to know the mass and the volume. We're going to start off today by learning about volume. Volume is the amount of space occupied by an object. We can find the volume of two different types of objects. The first type of object is one with a regular shape. This is like a brick. A brick is a solid rectangular prism. In order to figure out its volume, we need to measure its dimensions. We need to measure the length, the width, and the height. Here is an example. The easiest way to do this is to pick one corner of an object and measure each edge that is attached to that object. So you can measure the length, the width, and the height that extend from that one corner. After you have measured the length, width, and height, multiply the three dimensions and their units together to find the volume. For the brick, the units will be in centimeters. Therefore, the units for volume are expressed in cubic centimeters or centimeters cubed. Here is an example. To find out how much a truck or boxcar will hold, measure the dimensions using larger units of meters. We can measure the length, the width, and the height. Therefore, the volume is expressed in cubic meters or meters cubed. We can also find the volume of irregular shapes. To measure the volume of an irregularly shaped object, like a rock, something that is not rectangular in shape, first we get a graduated cylinder in which the irregular object will easily fit. Second, pour water into the cylinder to half the total volume the cylinder can hold. Then record the volume of the water. Here in this example, the first volume is 80 milliliters. Next, drop the object gently into the cylinder and record the new volume. Here the new volume is 120 milliliters. Then subtract the old volume from the new volume. 120 milliliters minus 80 milliliters equals 40 milliliters. The volume of the rock is 40 milliliters. We now know how to determine the volume of both regular shaped and irregular shaped objects. In order to determine density, we need to know mass and volume. So next, we will be learning how to determine the mass of an object. Mass is defined as a measurement of the amount of matter in an object. The mass of an object stays the same even if on a different planet. That's because the object will still be made up of the same amount of matter. Can you think of something that would change if on a different planet? If you said weight, you are correct. Weight is the gravitational pull on an object from the planet. If you were to travel to Pluto, which has a smaller gravitational pull, then you would weigh less on Pluto than on Earth. However, your mass would stay the same. You would still be made up of the same amount of matter even if you were on Pluto. Baseball and tennis balls have about the same volume. That is, they take up about the same amount of space. But if you pick them up, you notice a difference. The baseball has more mass. A block of aluminum and a block of silver look very similar. In this picture, they have the same volume. However, aluminum has an atomic mass of 26.98, while silver has an atomic mass of 107.87. Silver has a much greater mass than aluminum. The aluminum and silver have several properties in common and some properties that make them different. In the picture, they had the same volume. Both aluminum and silver are shiny. Aluminum is a poor conductor of electricity, while silver is a good conductor of electricity. They are both good conductors of heat. Aluminum and silver are both solids at room temperature, and they are both silver in color. However, the atomic masses of aluminum and silver are very different. Aluminum and silver are also made up of different elements. The element aluminum and the element silver. Aluminum has 13 protons, while silver has 47 protons. This is why silver has a greater atomic mass, because it is made up of more matter or more protons. Aluminum has a lower melting point than silver, and silver has a lower boiling point than aluminum. Based on the properties of aluminum and silver, why is aluminum used to build airplanes rather than silver? Think about it. You might have said that aluminum is easier to find than silver, and so it's less expensive. That is one reason that airplanes are built out of aluminum. You might have also said that aluminum has less mass than silver. This is important because airplanes have to be able to fly. So aluminum has less mass per volume than silver would have, which makes the airplane lighter and more easily able to fly. This is what we call density. So one property that makes aluminum different from silver is the property of density. Aluminum has less mass per volume than silver. Density is defined as the mass of a substance per unit of volume. You could also say that density is the amount of matter packed into a given space. These three blocks have the same volume. One is wood, one is plastic, and one is metal. But their masses are very different. The metal has the greatest mass per volume, so we would say that it is more dense. Now I want you to close your eyes and imagine a very dense fog all around you. Does this mean that there is more fog or less fog? Hopefully you said that it means it's more fog. Now I want you to imagine a very dense forest. Does that forest have just a few trees, or does it have a lot of trees? A very dense forest has a lot of trees packed tightly together. Now one more thing to imagine. Imagine a very dense cube. Would that cube have a lot of atoms or very few atoms? A very dense cube has a lot of atoms tightly packed together. The more matter you have packed into a given space, the more dense an object is. Hopefully you can now picture the idea of density a little bit better. In order to find the density of an object, you need to know the mass and the volume. The formula or the equation for density is density equals mass divided by volume. You can also switch the equation around to find the mass or the volume. Mass equals density times volume, or volume equals mass divided by density. You will be learning more about the density triangle pictured here in a future video. Now for an example. To calculate the density of an object, first determine the volume of an object just like we showed earlier in the video. You can use a graduated cylinder to find the volume of an irregularly shaped object, or you can measure the length, width, and height of a regular shaped object and multiply them to find the volume. Then record the volume in milliliters or in centimeters cubed. Milliliters are the same as centimeters cubed. If the object that you're trying to find the density of is a liquid, use milliliters. If it is a solid, use centimeters cubed. Next, determine the mass of the object. Sometimes, in an example problem, this is given to you. If you actually need to find the mass of the object, do you know what tool you would use? You're right if you said a triple beam balance. Finally, divide the mass by the volume to determine density. The units for density are grams per milliliter for liquids or grams per centimeter cubed for solids. So in summary, to calculate density, you find the volume, you find the mass, and then you do mass divided by volume equals density. Don't forget your units. Here are the densities of some common materials. Notice that the density of water is 1 gram per milliliter. If an object has a density that is greater than 1, then it will sink in water. Which objects or which materials listed here will sink in water? Aluminum, lead, gold, and sugar will sink in water. Ice, helium, air, cork, and balsa wood will float. You now have 4 questions to answer for homework. These will be due on Monday. Answer the questions on your own piece of paper. Write incomplete sentences, show your work, and do copy the question. You can pause the video here while you take the time to answer the questions on your own sheet of paper. You may also rewind the video and review anything that you feel is necessary. Turn your answer page in when you come to class on Monday, and thank you for learning more about density.